Hey guys, in this video, I'm going to show you some examples on putting an equation that's in standard form to slope-intercept form. So, slope-intercept form is an equation that is in the form y equals mx plus b. And standard form is when an equation is in the form ax plus by is equal to c. So if you look at the equations, the examples that we have here, um, this is like ax plus by equals c. It doesn't matter that the terms are like on different sides. Um, ax, by, c. So we want to convert these equations from standard form to slope-intercept form, right? We want to make it say y equals something x plus b, right? A value for our y-intercept. So essentially, all we're doing is solving for y, right? If we try to get y by itself, then we'll have an equation that says y equals, right? That's all you have to think about. Solve the equation for y. So we're going to use inverse operations to do that. So in the first examples, if I were trying to get the 2y by itself on the left side, I would need to move this negative 10x over to the right side of the equation. To do that, I use inverse operations. I do the opposite that's happening here. So since this is a negative 10x, I would do positive. So I would add 10x. And whatever you do to one side of an equation, you do to the other side. So I would add 10x to both sides. So if we do that, add 10x to both sides, negative 10x plus 10x is going to cancel out, and we'll be left with 2y is equal to 18 plus 10x. Since this 18 and the 10x are not like terms, we can't combine them, right? We can't say that this is 28 or 28x. So we just rewrite them individually when we rewrite our equation, right? So I separated the 18 and the 10x. Now we have 2y by itself on the left side. So I need to finish solving for y by dividing both sides by the number that's in front of y, right? By the coefficient. So our coefficient here is 2. So I'm going to divide both sides by 2. 2y divided by 2. The 2's are going to just cancel out. So we're going to be left with y is equal to 18 divided by 2 is just 9. So y is equal to 9. And then 10x divided by 2 is just 5x. So y is equal to 9 plus 5x, right? So here it's in the form y equals, but it's not fully in slope-intercept form because slope-intercept form is y equals mx plus b. The we would need to write the slope first. So if we put it completely in slope-intercept form, we would have y equals 5x plus 9, right? Where we write our slope first, right? That 5x goes first. So now it's in the form y equals mx plus b, where m is our slope and our y-intercept is 9. But essentially, these two are the same equations. It's just that this one is completely in slope-intercept form. Okay, looking at the second example, we have x minus y is equal to 3. If I'm trying to put this in slope-intercept form, I'm just solving for y. So my first step to get negative y by itself would be to move this x over to the other side of the equation. Since x is positive here and I need to move it, I'm going to do the opposite. So I'll subtract x from both sides. X minus x will cancel out and we'll be left with negative y is equal to 3 minus x. Again, these are not like terms, so I can't combine them. So I just rewrite them individually in the new equation. My last step here to completely solve for y, to get y completely by itself and to get rid of this negative, would be to divide both sides by -1, right? There's an invisible 1 in front of this y, and since this is -1 times y, we know that the opposite of multiplication is division. That's why we're dividing both sides by -1. So my negatives will cancel, and we'll have y is equal to -3 plus x. 3 divided by -1 is -3, and negative x divided by -1 is just positive x. So now it's in the form y equals. We can easily graph this, but it's not fully in slope-intercept form. Um, in slope-intercept form, we need to write the slope first, right? We need to write the variable first, the mx. So that would be y is equal to x minus 3. And that's all there is to putting an equation that is in standard form to slope-intercept form. So let's look at two more examples. 3x minus y is equal to -7. So I want to get this negative y by itself. So my first step is going to be to move the 3x over to the other side. Since it's positive here and I need to do the opposite, I'm going to subtract 3x from both sides. This will cancel, and we'll be left with negative y is equal to -7 minus 3x. Last step here to fully solve for y is to divide both sides by -1. My negatives will cancel, and we'll have y is equal to 7 plus 3x. -7 divided by -1 is +7. And -3x divided by -1 is +3x. And our last step to put this completely in slope-intercept form is to just rewrite the equation with the slope first. So we'll have y is equal to 3x plus 7. And then in the last equation, we have 2x plus 3y is equal to 15. So I need to get this 3y by itself on the left side, so I need to move the 2x over to the other side. Since it's positive here and I need to do the opposite to move it, I'm going to subtract the 2x from both sides. This will cancel, and we'll be left with 3y is equal to 15 minus 2x. Last step to get the y completely by itself, to solve for y, we're going to divide both sides by 3. That will cancel out, and we're left with y is equal to 5 minus 2 over 3x. So notice that we have -2x divided by 3 here, right? So we can do two things. We can leave this as a fractional slope, or we can convert it to a decimal, right? If we converted that to a decimal, 2 divided by 3 would just be 0.66666667. But since that's the weird decimal and that will not help us if we were to graph this, we're going to leave it as a fraction. And then, of course, to put this completely in slope-intercept form, we'll write the slope first. So that would be y is equal to -2 over 3x plus 5. Why did my box turn pink? Box is not boxing here. Okay, cool. All right, so that's all there is to converting an equation that is in standard form to slope-intercept form. When we have an equation that's in slope-intercept form, y equals mx plus b, it's very easy to graph because we know we would start at the y-intercept, and then we would use the slope as our rise over run um, to graph. All right, I hope this was a little bit helpful. Bye.